And if you're unsure, Google it or look it up. If you're unsure of formulas, if you forget them. Like I think if we don't get to it today, I might do something with a sphere, and if you don't remember volume of a sphere, it's 4/3 pi r cubed, because it's volume. But if you don't remember, look it up. I don't expect you to memorize the surface area or volume of all of the shapes. We should know how to do a box, right? Length times width times height. Okay. All right, so then, let's see, what are we supposed to do here? What is being asked? Let's highlight that. What is being asked? Because there's a lot of info in here. What are we trying to find? So this is what we call in the formula, okay, in the formula, what variable is the depth of the cone? H. In calculus terms, what I am going to be trying to find is the rate of change of H. We call that dH dt. That is what we are trying to find. Okay. Draw a picture. Cool. Did it. Summarize info. Okay, we did that. We should probably write the volume equation down, right? Okay. So here's the deal. If I want to find dH dt, I'm going to need to take the derivative of this, okay? And plug in different things. Here's why I give you this information. Because I don't want that r in there. I have no interest in the problem at all in what dr dt is, do I? So what I'm going to use is this information to swap out the r, and here's how I'm going to do it. No matter what, so if the water was here, let's say the water was down here. That radius is not 5, correct? And that height is not 12. But they are still the same proportion, okay? So the ratio of R to H is still 5/12. The ratio of R to H is consistent throughout. So what that gives us is a formula that I can solve. Let's cross multiply. 12R equals 5H. Are you with me? If I wanted to get rid of the R, I could replace R then with 5/12H. Let's do it. So here's what we're going to do. We are going to write a new formula so we only have H's in it. And then because I want to find the rate of change of this, the next step is I'm going to take the derivative of it. Okay? And then I'm going to solve for dH dt. So V equals 1/3 times pi times the radius squared. Because I don't want you guys to make computational mistakes, I'm going to actually write out the radius 2 times. That's 5/12H times 5/12H times H. Are you still with me?
Yes.
So this is the radius squared. Okay. All right. Let's keep going. I am going to write then 5 times 5 is what? 25. Gosh, 12 times 12 times 3. Right? 12 times 12 is 144 times 3. Agreed? Okay. we need a pi, and we need an h cubed. Okay, so remember, what are we trying to find? DHDT. I'm going to highlight some other things that you're given just so you know. I give you this rate. What is this rate? Rate of change of what is that? Tell me what it is though. The rate of change of the what? Cubic feet is a measurement of volume. This is dV dt. I give you that, okay? Just so you're aware. I also give you the height in the equation. So in a minute, once I take the derivative, I'm going to give you all of the things you need to solve except dH dt. You're going to have one unknown. All right, so here we go. Now I take the derivative. But I remember my rules about implicit differentiation. What's the derivative of v? dV dt. That's the change in volume with respect to time. What happens to this 3? Comes out to the front. So 3 times 25 is 75 over 432 times pi. That's just a number, guys. Remember? It stays in there. Times h squared times dH dt. Now we plug in values. By the way, be careful. If water is flowing into the conical tank, the volume is getting bigger, right? So dV dt is positive. If it's flowing out, is the rate of change going to be positive anymore? No. So be careful in the problems today. Flowing in is positive, flowing out is negative. So this is positive. All right, what can I put in? Charles says dV dt is 10. Do you understand where he gets that from? Is it the 10 feet across? No, it's the 10 cubic feet per minute. It's the rate of the change of the volume. Okay. What else do I know? I want to know when the water is 8 feet deep. So I'm going to put in 8 for H. Okay, now we're going to solve this without our calculator at first, and if you don't reduce fractions, it's not the end of the world. That's all I'm going to say about that. They aren't going to mark you down when it's something this nasty for reducing fractions. Okay, so let's see here. I'm going to do this in steps to make my life a little easier. I am going to multiply by the reciprocal. So I'm going to multiply by 432 pi over 75. So I just got rid of that, right? Are you with me? Almost there. What do I have to do to get DHGT alone? Divide by 64? 8 squared? Okay. So I just put it on the bottom with that. Okay. Now, if you do the reducing on this, this fraction actually reduces again, and we would be left with 1,440 divided by 1,600 pi. My bad. This pi should not be on the top of the fraction. It should be on the bottom of the fraction because it's on the top up here. And let's get our calculators out. Can you tell me to 3 decimal places what that is about? You sure? Did you use parentheses?
Let me check.
Okay, this is a change in height. What are going to be the units on this? Feet per